Introduction.
Hey Ajay, look at the stars.
Wow, they're looking so beautiful. They look like points.
Yes. Do you know what do we get if we join 2 points?
Yes, we get a line.
See that Big Dipper? Here, all the 7 stars are joined.
And Didi, what happens when 2 lines intersect each other?
Good question. When 2 lines intersect each other, then angles are formed. Come, I will tell you more about lines and angles and their properties.
Objectives. At the end of this lesson, you'll be able to define line, line segment, ray and angle. Differentiate between intersecting lines and non-intersecting lines. Relate between the angles formed when a ray stands on a line. Write the axioms based on pairs of angles. Prove the given theorems. Find relation between parallel lines and transversal. Prove theorems and examples related to lines parallel to the same line. Prove the angle sum property of a triangle. Basic terms and definitions. We know that a part or portion of a line with 2 endpoints is called a line segment. The line segment AB is denoted by this symbol. A part of a line with 1 endpoint is called a ray. The ray AB is denoted by this symbol. And the line is denoted by this symbol. We also know that if 3 or more points lie on the same line, they are called collinear points. Here, A, G, F are called collinear points. And points B, C and E are called non-collinear points. Now come to an angle. An angle is formed when 2 rays originate from the same endpoint. The rays making an angle are called the arms of the angle, and the endpoint is called the vertex of the angle. We know about different types of angles like acute angle, right angle, obtuse angle, straight angle, and reflex angle. Let's go through them one by one. Types of angles. An acute angle measures between 0 degree and 90 degree. A right angle is exactly equal to 90 degree. And an angle greater than 90 degree but less than 180 degree is called an obtuse angle. Also, a straight angle is equal to 180 degrees. And an angle which is greater than 180 degrees but less than 360 degree is called a reflex angle. We also know that 2 angles whose sum is 90 degree are called complementary angles. What do we call the angles whose sum is 180 degree? Yes, you are right. They are called supplementary angles. Types of angles. Another question for you. What do we call those angles which have a common vertex, a common arm, and their non-common arms are on different sides of the common arm? They are called adjacent angles. Here ABD and DBC are adjacent angles. Ray BD is their common arm and point B is their common vertex. Ray BA and ray BC are non-common arms. Also, when 2 angles are adjacent, then their sum is always equal to the angle formed by the 2 non-common arms. So we can write angle ABC is equal to angle ABD plus angle DBC. If the non-common arms B and BC form a line, then it will look like this. Then the angles ABD and DBC are called linear pair of angles. When 2 lines, say AB and CD, intersect each other, say at a point O, then the angles formed are called vertically opposite angles. These are two pairs of vertically opposite angles. One pair is angle AOD and angle BOC, and the other pair is angle AOC and BOD. Intersecting lines and non-intersecting lines. Now let us draw two different lines PQ and RS on a paper. We can draw it in this way also. We have seen that we can draw them in two different ways. These are intersecting lines and these are parallel lines. And the length of the common perpendiculars at different points on these parallel lines is the same. This equal length is called the distance between two parallel lines. Pairs of angles. Now let us find out the relation between the angles formed when a ray stands on a line. Look at this figure. Here AB is the line and OC is the ray. Angle AOC, angle BOC, and angle AOB are the angles formed at O. Can we write angle AOC plus angle BOC is equal to angle AOB? Yes, because angle AOC and angle BOC are adjacent and angle AOB is the angle formed by the two non-common arms, and we have studied that when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. Mark it as 1. The measure of angle AOB is 180 degree because it is a straight line. Mark it as 2. From 1 and 2 we can say that angle AOC plus angle BOC is equal to 180 degree because angle AOB is 180 degree. This gives an axiom. Let's go through it. Axiom 1. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. We know that if the sum of two adjacent angles is 180 degree, then they are called a linear pair of angles. Given that a ray stands on a line, from this we can conclude that the sum of two adjacent angles so formed is 180 degree. Let us write this axiom the other way. That is, we will take the conclusion of the axiom as given and the given as the conclusion. So it becomes, if the sum of two adjacent angles is 180 degree, then a ray stands on a line, that is, the non-common arms form a line. Now we can see here that the axiom and this statement are reverse of each other's. Let us now check whether this statement is true or not. Draw adjacent angles of different measures. Keep the ruler along one of the non-common arms in each case. You will find that only in this figure, both the non-common arms lie along the ruler, that is, points A, O, and B lie on the same line and ray OC stands on it. Also, we can see that angle AOC plus angle COB is equal to 125 degree plus 55 degree, which is equal to 180 degree. From this, we may conclude that this statement is true. And we can state it in the form of another axiom, which is, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. Axiom 2. We get two axioms now. These two axioms together is called the linear pair axiom. Let us now move to the case when two lines intersect each other. We know that when two lines intersect, the vertically opposite angles are equal. We will prove this result after a small interactivity. Theorem 1. If two lines intersect each other, then the vertically opposite angles are equal. Let's prove this theorem. In this statement, it is given that two lines intersect each other. So, let AB and CD be two lines intersecting at O. They lead to two pairs of vertically opposite angles, namely degree AOC and degree BOD, degree AOD and degree BOC. We need to prove that degree AOC is equal to degree BOD and degree AOD is equal to degree BOC. Now, ray OA stands on a line CD. Therefore, degree AOC plus degree AOD is 180 degree. Linear pair axiom, mark it as 1. Similarly, angle AOD plus angle BOD is equal to 180 degree. Mark it as 2. From 1 and 2 we can write angle AOC plus angle AOD is equal to angle AOD plus angle BOD. This implies that angle AOC is equal to angle BOD. Similarly, it can be proved that angle AOD is equal to angle BOC. Parallel lines and a transversal. Friends, we have studied that a line which intersects two or more lines at distinct points is called a transversal. Look at this figure. Here, line L intersects lines M and N at points P and Q respectively. Therefore, line L is a transversal for lines M and N. Observe that four angles are formed at each of the points P and Q. Let us name these angles as angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. Angle 1, angle 2, angle 7 and angle 8 are called exterior angles, while angle 3, angle 4, angle 5 and angle 6 are called interior angles. We have also studied that when a transversal intersects two lines, we get some pairs of angles. Let's go through them one by one. First is corresponding angles. These are angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 8, angle 3 and angle 7. Second is alternate interior angles. Those are angle 4 and angle 6, angle 3 and angle 5. Then comes alternate exterior angles, and they are angle 1 and angle 7, angle 2 and angle 8. Next is interior angles on the same side of the transversal. These are angle 4 and angle 5, angle 3 and angle 6. Interior angles on the same side of the transversal are also referred to as consecutive interior angles or allied angles or co-interior angles. Now let us find out the relation between the angles in these pairs when line M is parallel to line L. So, with ruler and pencil, draw two parallel lines along any two of these lines and a transversal to intersect them. Now, if we measure any pair of corresponding angles, we find that angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. For this, we get one more axiom, which is, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. This axiom is also referred to as the corresponding angles axiom. Now let us discuss the converse of the axiom. If a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel. Does this statement hold true? Let us verify it. Draw a line AD and mark points B and C on it. At B and C, construct angle ABQ and angle BCS equal to each other. Produce QB and SC on the other side of AD to form two lines PQ and RS. We can observe that the two lines do not intersect each other. We can also draw common perpendiculars to the lines PQ and RS at different points and measure their lengths. You'll find it the same everywhere. So we can say that the lines are parallel. Therefore, the converse of corresponding angles axiom is also true. So we have got one more axiom for this, which we will discuss in next screen. Axiom 4 and Theorem 2. The axiom we get in previous screen is, if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Now we will use corresponding angles axiom to find out the relation between the alternate interior angles when a transversal intersects two parallel lines. Here transversal PS intersects parallel lines AB and CD at points Q and R respectively. We know that angle PQA is equal to angle QRC by using corresponding angles axiom. Mark it as 1. Also, angle PQA is equal to angle BQR because these are vertically opposite angles. Mark it as 2. So from 1 and 2 we may conclude that angle BQR is equal to angle QRC. Similarly, angle AQR is equal to QRT. This result can be stated as a theorem, which is, if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. Theorem 3. Now using the converse of the corresponding angles axiom, we can show the two lines parallel if a pair of alternate interior angles is equal. Come, let us check. Here the transversal PS intersects line AB and CD at points Q and R respectively such that angle BQR is equal to angle QRC. Also, angle BQR is equal to angle PQA because these are vertically opposite angles. Mark it as 1. But angle BQR is equal to angle QRC given. Mark it as 2. So, from 1 and 2 you may conclude that angle PQA is equal to angle QRC. But they are corresponding angles. So AB is parallel to CD, converse of corresponding angles axiom. This result can be stated as a theorem, which is, if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Theorem 4 and 5. There are two more theorems related to interior angles on the same side of the transversal. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. If a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Lines parallel to the same line. Let us now check that if two lines are parallel to the same line, then they will be parallel to each other. Look at this figure. Here line M is parallel to line L and line N is parallel to line L. Let us draw the line T transversal for this line L, M and N. It is given that line M is parallel to line L and line N is parallel to line L. Therefore, by using corresponding angles axiom, we can say that angle 1 is equal to angle 2 and angle 1 is equal to angle 3. So from these two we can say that angle 2 is equal to angle 3. But angle 2 and angle 3 are corresponding angles and they are equal. Therefore, by using converse of corresponding angles axiom, we can say that line M is parallel to line N. And this result can also be stated in the form of a theorem. Lines which are parallel to the same lines are parallel to each other. Example. Now let us solve some examples related to parallel lines. Given that if PQ is parallel to RS, angle MXQ is equal to 135 degree and angle MYR is equal to 40 degree, find angle XMY. For solution, we need to draw a line AB parallel to line PQ through point M. Now AB is parallel to PQ and PQ is parallel to RS. Therefore, AB is parallel to RS because two lines parallel to the same line are parallel to each other. Now, angle QXM plus angle XMB is equal to 180 degree. AB is parallel to PQ, interior angles on the same side of the transversal XM. But angle QXM is equal to 135 degree, so 135 degree plus angle XMB is equal to 180 degree. Therefore, angle XMB is equal to 45 degree. Mark it as 1. Now angle BMY is equal to MYR because AB is parallel to RS, so these are alternate angles. Therefore, angle BMY is 40 degree. Mark it as 2. Now adding 1 and 2 we get angle XMB plus angle BMY is equal to 45 degree plus 40 degree. Hence, angle XMY is equal to 85 degrees. Angle sum property of a triangle. Can you tell what is the sum of all the angles of a triangle? Yes, you are right. The sum of all the angles of a triangle is 180 degree. Let us prove this statement using the axioms and theorems related to parallel lines. Property is, the sum of the angles of a triangle is 180 degree. We are given a triangle PQR and angle 1, angle 2 and angle 3 are the angles of triangle PQR. We need to prove that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. Let us draw a line XPY parallel to QR through the opposite vertex P. Now XPY is a line, therefore angle 4 plus angle 1 plus angle 5 is equal to 180 degree. Mark it as 1. But XPY is parallel to QR and PQ, PR are transversals. So angle 4 is equal to angle 2 and angle 5 is equal to angle 3 because these are pairs of alternate angles. Now by substituting angle 4 and angle 5 in 1, we get angle 2 plus angle 1 plus angle 3 is equal to 180 degree. Or we can write it as angle 1 plus angle 2 plus angle 3 is equal to 180 degree. Theorem 8. Do you remember about the exterior angle of a triangle? Look at this figure. Here side QR is produced to point S. Angle PRS is called an exterior angle of triangle PQR. Is angle 3 plus angle 4 is 180 degree? Yes. Angle 3 plus angle 4 is 180 degree because these are linear pair angles. Mark it as 1. Also, angle 1 plus angle 2 plus angle 3 is equal to 180 degree because the sum of all the angles of triangle is 180 degree. Mark it as 2. From 1 and 2 we can say that angle 4 is equal to angle 1 plus angle 2. This result can be stated in the form of a theorem which says, if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of the two interior opposite angles. It is obvious from this theorem that an exterior angle of a triangle is greater than either of its interior opposite angles. Now let us solve some examples based on this theorem. If QT is perpendicular to PR, angle TQR is equal to 40 degree and angle SPR is equal to 30 degree. Find X and Y. Solution. In triangle TQR, 90 degree plus 40 degree plus x is equal to 180 degree because the angle sum property of a triangle. Therefore, x is equal to 50 degree. Also, y is equal to angle SPR plus x because we know that if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of the two interior opposite angles. Therefore, y is equal to 30 degree plus 50 degree, which is 80 degree. Did you know the names alternate interior angles, alternate exterior angles, corresponding angles, and interior angles on the same side of the transversal are used to describe specific angles formed when lines intersect? These names are used both when lines are parallel and when lines are not parallel. Summary. Let us summarize what we have learned. If a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degree and vice versa. This property is called as the linear pair axiom. If two lines intersect each other, then the vertically opposite angles are equal. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal, each pair of alternate interior angles is equal, and each pair of interior angles on the same side of the transversal is supplementary. If a transversal intersects two lines such that either any one pair of corresponding angles is equal, or any one pair of alternate interior angles is equal, or any one pair of interior angles on the same side of the transversal is supplementary, then the lines are parallel. Lines which are parallel to a given line are parallel to each other. The sum of the three angles of a triangle is 180 degree. If a side of a triangle is produced, the exterior angle so formed is equal to the sum of the two interior opposite angles.